Hello friends, welcome to my channel An Engineer's Guide. In the previous three sessions, we learned about MDMT, how to use the clause UG20F and figure UCS66. In this session, we will build on that topic and take it step further. If you haven't watched those three videos yet, I highly recommend you check them out first and then return to this one. In this session, we will continue with the example we started in the last session. But before moving forward, please subscribe to my YouTube channel, which will be free for you, but it provides me with the motivation to create a more useful content like this. Also, don't forget to click on the bell icon to stay updated with the latest videos from our channel. In the last session, we calculated the basic MDMT. In this session, we will focus on calculating the reduced MDMT. This might be the final part of the MDMT calculation series. However, if possible, I will try to expand this topic further to include the MDMT calculation for different components, such as dish head, flat heads, flanges, etc. That's it. I also have some other interesting topics to explain, but for today, let's concentrate on how to calculate the reduced MDMT. Now let's understand the minimum required thickness. The minimum required thickness refers to the thickness needed in the corroded condition for all applicable loadings as listed in UG22 based on the applicable joint efficiency at MDMT temperature. Here, the term MDMT temperature is particularly important. Also, one more thing you have to note, in our case, we are considering only internal pressure as a loading for ease of understanding. Otherwise, there are different types of loadings are mentioned in the UG22. You just go and check the clause UG22. There you will find different types of loadings such as internal pressures, external pressures, wind loads, seismic loads, all etc. Once again, I am showing the input we have considered, so please review them carefully. A very important concept here is the finish thickness we considered as being available in the market. In general, we always assume that the finish thickness to be slightly higher than the design thickness as obtained from the calculations, as design thickness is simply the minimum required thickness plus corrosion allowance. In practice, the thickness available in the market is referred to as nominal thickness. However, for components like shell, finish thickness is same as that of the nominal thickness. But for dish end, the finish thickness and nominal thickness differ because we must account for the forming or thinning allowance. In such cases, the finish thickness is calculated as nominal plate thickness before forming minus forming or thinning allowance. Generally, the forming or thinning allowance is considered to be 10%, but this can vary from vendor to vendor. For reference, you can consult table 2-17 thinning allowance for heads from Denismos. However, it's always good practice to consult with the dish end manufacturer to confirm the specifics. Now let's move on to the calculations. Here you can see the simple formula used for thickness calculation, which is based on the UG27. The key point to remember here is allowable stress values. The allowable stress values must be considered at MDMT, means minimum design metal temperature. In our case, the design temperature is 100 degrees Celsius and the MDMT is minus 32 degrees Celsius. Therefore, I must consider the allowable stresses at minus 32 degrees Celsius, not at 100 degrees Celsius. If you don't know how to find the allowable stress values, we have some another videos on our channel. You just go and check that video so you will understand how to find the allowable stress values. Now, as you know, ASME section 2 part D provides allowable stress values starting from 40 degrees Celsius. In such cases, we should use the allowable stress values at 40 degrees Celsius or room temperature as we can call it. In my case, allowable stress values at 40 degrees Celsius and 100 degrees Celsius are same, so there is no discrepancy here. However, don't get confused. If your design temperature is, for example, 300 degrees Celsius, you must still use the allowable stress value at MDMT temperature. If the allowable stress values at MDMT isn't available, you should use the value at room temperature. Now let's see the answer. TR is equal to 18.62. So this is what your minimum required thickness is. Now let's calculate the thickness ratio, which is the critical parameter here. The formula for this can be found in figure UCS 66.2. As we already know, our minimum required thickness is 18.62 mm and the nominal thickness is 24 mm. Simply substitute those values into the formula to get the answer. So here our answer is 0.89. An important point to keep in mind is the joint efficiency E star value. The joint efficiency E star should be the maximum of the value obtained from table UW12 or 0.8. This means the minimum E star must be 0.8 and any value below that is not permitted. Additionally, make sure to review the notes provided in figure UCS 66-1 and figure UCS 66.2 for further clarity. Now we have all the input values. Let's calculate the reduced MDMT using figure UCS 66.1. I am showing you the sample figure here, but I strongly recommend referring to exact figure from the code for accurate results. Let me explain this figure. The horizontal axis represents temperature and the vertical axis represents the thickness ratio. In our case, thickness ratio is 0.89. To use this figure, draw a horizontal line at 0.89 on the vertical axis. Where this horizontal line intersects the curves, draw a vertical line. The point where vertical line meets the horizontal axis gives the temperature reduction. In our case, the temperature reduction is 6 degrees Celsius. Therefore, the reduced MDMT is basic MDMT from figure UCS 66M plus reduction in MDMT from figure UCS 66.1. So in our case, reduced MDMT will be minus 36 degrees Celsius minus 6 degrees Celsius is equal to minus 42 degrees Celsius. If your thickness ratio is less than 0.35, refer to UCS 66B3. This scenario usually occurs when the nominal thickness is significantly higher than the design thickness. Under this condition, the code allows for exemptions from impact testing with a temperature allowance of up to minus 105 degrees Celsius. So I will highly recommend you just go to the clause UCS 66B. Read that carefully and get your confirmation on this. Now let's verify the PV-Light results. As you can see, our calculated values for the basic MDMT and reduced MDMT matches. So guys, this is all about today's session. I probably cover a new topic in the next session. Until then, please stay tuned, and if you find our videos useful, please share them with your friends and colleagues. Thank you and goodbye. Keep learning, keep earning, and have a happy weekend.